All right, guys, just a real quick addition to our robot work. I thought it might be fun if you guys could do circles if you wanted to. That would be something to add to either excuse me, an area of your robot or a surface area for the third year. So I'll show you how to do both. Obviously, you're going to want to start with some way to draw a circle. I have these cool templates here that you guys probably don't have here, but they even have things on them that list how big each of these are. So I automatically already know the diameters of these circles. And remember, diameter means when I do my circle, it means from one edge of the circle through the center, which I'm just going to kind of estimate here, to the other edge. That is my diameter, right? So that would be a capital D, and in this case I know because of my template that would equal 2 inches on this one. If you have a compass, some of you guys might have a compass, and that is pretty cool to know also ahead of time, because on the scale on the compass it actually says this side is metric. You guys probably can't see it, but I'll trust me, it says metric centimeters. So if I put it at the, let's say 4 centimeter mark, and I put my point in the middle, then I will know that I just drew a circle that has a diameter of 4 centimeters. So I can do that one. Now, you may not have either of those two things. So what you could do is just find something around your house. You might even have one of these. This is just a cap to a pill bottle. Don't go digging around your family's pills. Ask your parents' permission to find a pill bottle cap. The reason why these are good, and you may not be able to see it, but this actually has a little dot right in the middle that was formed into the plastic. And the reason why that is great is because then when I measure it to see how big this cap is, I put my ruler on it, I can actually go edge through the middle to the other edge, and this is a 1.5 inch pill bottle cap. So that's really cool. So when I trace this, and this is what most of you may be doing if you decide to do some circles, is tracing something like that, and then saying your diameter equals, excuse me, 1.5 inches. So that's great. We know what all these diameters are. Now, how is that going to help us when we're trying to figure out what the area of them are? Well, remember, our formula for area is the area of a circle is pi, and we're all going to represent pi by 3.14, and that goes for whatever unit of measure that we're doing, whether it's centimeters or meters, or not meters, but centimeters, inches, or even units if you're, well, I don't know how you do units on this one, but anyway, probably centimeters or inches. And then area is pi times the radius squared. Okay, so what's the radius? Well, remember, the radius is just half of the diameter. So for this one, for instance, the diameter goes one edge through the middle to the other edge, while the radius is just from the middle to the edge. It's half the diameter, right? There's one half, there's the other half. So in this case, the radius is 1 inch. And in this case, the radius is 2 centimeters. And in this case, the radius is 3/4 of an inch. You guys could do the math on how to get 1.5 cut in half. Second and third years at least. So now we know our R. Right, so then I can do my area equals, let's do this one because this is going to be super simple, 3.14 times 1 squared. Well, remember, squared just means take this number, the base number, and multiply it times itself. That's all squared means, so 1 times 1 is 1. So in this case, our area for this circle happens to just be 3.14 square inches. That's this one. Our area is 3.14 square inches. Great. All right, so if you're just doing a circle, that's good. That's going to work out for you just fine. Now, if you're a third year and you're doing 3D, what you're going to have to do then is do a cylinder, right? So a cylinder, this is actually even kind of a cylinder because you have obviously a flat circle face, but then you're going to have this face that wraps all the way around the circle. But if you took that edge off, that face that goes all the way around, and undid it, you'd actually have a rectangle. So what that would look like is that would be, you know, you have, imagine your cylinder, a little longer one, the one that we're more used to seeing, right, looking like that. Well, this face down here is a circle, and this face up here is a circle. And if I take this thing and unfold it or unwrap it from those two circles, it just ends up being a rectangle, right? And I can get the area of a rectangle, no problem. So here's my top face, here's my bottom face of my circle, here's my edges of my rectangle. And that is all it takes to form that surface area of a cylinder. So I can find these areas depending on what those circles, the radius of those circles are. I can find those areas, no problem. I can find this area, no problem, if I know my height, right? So that's my h, and I know my width. And the width here is going to be the same as the circumference of this circle. So we didn't find circumference yet. We found areas so far, but circumference also uses pi, and it's just as easy. Circumference is just going to be the diameter times pi. So let's go back to this one. What's the circumference of this circle? It's just 2 times 3.14, right? And that's just stacking up some numbers and doing the math. 2 times 4 is 8, 2 times 1 is 2, 2 times 3 is 6. There are 2 places behind a decimal, so 2 places behind a decimal. So that 6.28 or 6 28/100ths, that is my circumference in inches. So that would also be the length of this, the one that wrapped around the circle, side of my rectangle. So in order to find the surface area of this, I got the area of the circle, I got the area of this circle, those are going to be the same, so it's just doubling those up. And then I got whatever I chose for my height here to multiply that times my circumference of the circle here. All right, so that's just a little bit extra challenge for you guys. And if you did find that you wanted to add some circles to your robots, that's how that could work. Of course, as always, hit me up in Slack if you have any questions about any of that. And good luck in that challenge.